My training is in psychology, and I always felt that in order to understand the human mind, we have to understand the biology. So those were always my favorite subjects at university, and that's just continued to today. I've been studying nonverbal communication for the past couple of decades, and an important topic in my lab is social touch. So I'm interested in how we process the physical contact that we make during social touch from the skin to the brain. And yeah, I mean, it turns out, this work has been really inspired by studies that have been done in rodents, where Michael Meany's group has shown some really nice epigenetic effects in terms of showing that the amount of touch that offspring get during development is critical in shaping their resilience against stress and also their social behavior. And those are two things that are really important for psychologists, and so this has been something that we've been looking at. This being an ANT meeting, and we are doing EEG mostly in the lab, so in my presentation I've been focusing on what we've done with EEG, and one exciting thing is that we found, it looks like a marker in the EEG or event-related potential that helps us discriminate the processes that are triggered by different types of mechanoreceptors that are sitting in the skin. There is one type of receptor that's a C fiber, which has been discovered fairly recently, actually contributes to mechanosensation. And this particular fiber, called the C tactile afferent, seems to be particularly tuned to social touch. So it's responding preferably to stroking of a typical human stroking velocity, to human temperature, skin temperature, touch, and pressure. And so having a marker in the brain that allows us to study this receptor would be really cool. So yeah, so I've been showing some data that suggests that maybe we have such a marker. One thing that I've been looking forward to doing is to not only measure somatosensory processes with electrodes from the brain, but to also look at the spinal cord. So actually your team has been helping me to make some first steps in setting up some spinal recordings, and to see whether we can better track and relate what's happening at the skin to the kinds of processes that we're seeing in the brain, and to then really nicely delineate the contribution of the different somatosensory receptors or systems. Well, it's tough. So you have to come with a big passion, and you also have to come with a lot of resilience and capacity to deal with disappointments and downturns. And yeah, so it's not an easy road, but it's definitely one worth taking. It's been a fun meeting. I very much like the mixture of talks and people. So there have been some really exciting keynotes. And yeah, I mean, for me personally, very interesting has been all the work on oscillations that's been presented here. And it's really nice to see how this is applied to different modalities, or how people interested in different modalities are using Rolandic rhythms, alpha and beta oscillations, to kind of learn something about the brain, and then also how to translate that into clinical applications. So that's been really insightful. What I very much appreciate is that you're very much on the pulse of science and clinical practice, and that you're really making an effort in getting feedback and working with the people who need the technology. So that's great, and so for that reason I think you have a good future.